In today's bonus segment, I'm going to explain how to use non-integers as an intermediary step to arrive at the solution when balancing a difficult chemical equation. So, up until this point, we've used somewhat pretty chemical equations that were fairly simple to balance. However, what if for example, this problem here, the solution is not very pretty? Sometimes it's easy to, we'll say cheat to arrive at our solution. Um, and by cheating, we're going to break one of our rules, which the rule states that all coefficients must be whole numbers, must be integers, positive integers. Um, However, we're going to break that rule for a few seconds so that we can arrive at a solution that does follow that rule. So as long as by the end of the problem you change all of your coefficients to integers, you're safe. Um, because we cannot have half of a water molecule, for example. I'm not certain where you're going to cut it. You can't cut it. So since we can't have half of a molecule, we must have integers to represent our coefficient. So let me show you how to do that with this sample problem below. The sample problem states, write a balanced chemical equation to represent the complete combustion of octane. Octane's chemical formula is C8H18. Since this is a combustion reaction, when we think of combustion reactions, I think of fires or explosions, and I think most of us know that in order for a fire to burn, it needs oxygen. So one of our reactants will always be oxygen. Now, since we've got a combustion reaction between a hydrocarbon and oxygen, our products will always be H2O and CO2. All right, we're going to start to balance this chemical equation the same way that I've taught previously using our T-chart, where we have our CH and O, our CH and O. On the left, we start with 8 carbons, we start with 18 hydrogens, 2 oxygens, we start with 1 carbon, 2 hydrogens, and 1 oxygen. 3 oxygens, 1, 2, 3. All right, now I'm going to switch over to pencil. I recommend balancing all chemical equations in pencil because most probably at some point you're going to have to change your coefficients. The coefficients that you write while you're solving the problem may not necessarily be the ones that you write as your solution to the problem. So now that I've changed over to pencil, the first thing that we're going to balance are the carbons because they are combined with the most different elements, oxygen and hydrogen. So I see 8 on the left and 1 on the right, so we're going to put a coefficient 8 in front of CO2. I did not change anything on the left. We now have 8 carbons, 2 hydrogens, and 8 times 2 is 16, plus 1 is 17 oxygens on the right. Next, I'm going to go and change our coefficients to balance our hydrogens. Because oxygen is all by itself, I can just change that to whatever I need it to be in the end. So the next step is to make certain that we have 18 hydrogens on the right. In order to get there, I'm going to change the coefficient to a 9. So again, we didn't change anything on the left. Now we have 8 carbons, 18 hydrogens, and we now have 9 plus 16, which is 25 oxygens on the right. Now, there is absolutely no whole number that I can multiply 2 by to arrive at 25. It cannot be done. So this seems as though it's going to be a very difficult problem. However, I can multiply the number 12.5 by 2, and that'll give me 25. So that means that on the left I would have 8, 18, 25, 8, 18, 25. So at this point, this equation is balanced. However, we cannot have half of an oxygen molecule. And so we must do something to each of these coefficients to make sure that they're all whole numbers. If we multiply all the coefficients by 2, since there's an imaginary 1 here, that becomes 2. 12.5 becomes 25. 9 becomes 18. And 8 becomes 16. If we multiply all of these coefficients by 2, first you'll notice that they are not divisible by any number, any one single number. So I cannot reduce them. And then second, they are now whole numbers. Now let's check. Since we did multiply them all by the same number, they should balance out. However, we'll double check just to make sure. On the left, I have 16 carbons. On the right, I have 16 carbons. On the left, I have 18 times 2, which is 36 hydrogens. On the right, I have 18 times 2, which is 36 hydrogens. Now for our oxygens, we have 50 oxygens on the left. Now, on the right, I have 18 plus 16 times 2, which is 32. So 18 plus 32 gives us our 50 oxygens on the right. If you had used a conventional means through which to balance this, you probably would have taken quite a while to balance it. However, by cheating and using a non-integer in this step, that makes this problem much simpler. Hopefully this is beneficial, and hopefully this all will help. Good luck on your balancing chemical equation endeavors.